Greetings. From today onwards, in the next 2 or 3 classes, what we will do is we will talk about the analysis or analytical chemical aspects of atomic absorption spectrophotometry. Okay. So, here I am presenting you some of the technology nomenclatures, detection limits, methods and the applications of atomic absorption that will complete the course. So, in general what we are going to do is we are going to see the atomization conditions, analysis conditions, compare them with other hydride generation, cold vapor, mercury and electrothermal atomic absorption etc., followed by some nomenclature you should be very familiar if you want to work in atomic absorption spectrometry, and then we will go to the applications in various diverse fields where atomic absorption is normally employed or preferably employed. So, here is the comparison of the signal intensity. So, you can see I have plotted 1 to signal intensity is 1 to 10. Okay. These are the order of magnitude. That means, if I have a graphite signal, atomic absorption signal about 25%, the same signal will be approximately double if I use hydride generation, but you have to remember that hydride generation AS is not suitable for all elements. Okay. Similarly, flame is atomic absorption signal intensity is always higher than hydride generation AAS. Look at the ICP OES, this is inductive coupled plasma optical emission spectroscopy. It is also known as ICP AES or ICP MS also is there. So, if in ICP OES that is inductive coupled plasma, the signal handling can be up to 6 times, that is this is about 3 times, ICP OES is 6 times, ICP OES radial wave is about 7, it is on around 7, and dual wave is about 10 and ICP MS is about 9. So, this slide will show you the capabilities of signal handling in atomic absorption and other related techniques of elemental analysis, metal analysis. So, the next slide also is similar, but it will show you the conditions. Now, this is the slide I wanted to show you. In the flame detection limit ranges I am writing here. In the detection limits what we have is flame atomic absorption limits. So, the minimum you can go is about 1 ppb, that is the detection limit, that is the back side you should see. So, up to 100 ppb you can work, that means all the elements that can be determined using flame atomic absorption detection limits are of the order of 1 ppb to 100 ppb, that is for flame detection limit. That means, the absorbance should correspond to 0.004. So, that is actually a theoretical limit of signal handling, but determination limit would be approximately 100 times more than this. Similarly, you look at ICP, detection limit is approximately about 0.7 or 0.8 detection limit ppb, 0.8 ppb, and then it can handle up to 100 ppb. The range of detection limits for all elements fall within 0.8 to 100 ppb minimum detection limit. Look for ICP emission, it is about 0.02 or something like that, up to 10 ppb. Look at hydride generation, detection limit ranges from 0.001 approximately 0.005, that is 5 ppb, that is 5 parts per trillion, and then it goes up to 0.1 or 0.12 is the detection limit. All the detection limits of all the elements, that is arsenic, selenium, tellurium and bismuth, all the detection limits are in this range. For graphite furnace, it goes still further a little bit. So, it is about 0.001 ppb, that is almost 1 ppt, and then the maximum range of detection for the worst element would be somewhere between 1 to 10 ppb, that is approximately 5 ppb. For ICP-MS, there is the limit goes still down, that is the range is from 1 ppb to 0.0001 ppb or something like that. So, if you want to determine elements in parts per million, I am taking 1000 times detection limit, parts per million range, flame is your technique, preferred choice, and then ICP emission still lower you can work, and ICP radial, axial, hydride generation you stick only to arsenic, selenium, bismuth, tellurium etc., hydride forming including lead, and mercury nobody does this. Cold vapor mercury is only specific for atomic absorption. Graphite furnace, of course, it is for ppb quantitative determinations, and then ICP-MS would be quantitative in still lower range. All right. Now, what we will see is the practice of atomic absorption analysis. These areas I have taken, these next 10 to 20 slides I have taken from presently available manuals from the manufacturers. I for reasons of copyright etc., I will not reveal what are the which instrument this data is taken from, but you can say that 99% of the information will be available whenever in as a manual or on the CD or in the database in the computer when you buy an atomic absorption. But what information you should look for, that is the most important thing. So, I have taken an example, maybe about 10 elements I will talk about it. So, first thing is when you buy an atomic absorption, they will give you a manual. Manual may be CD or it may be printed copy also, but there they will specify the conditions for atomic absorption for different elements. For example, look at this, this is for silver. Okay. So, this is for silver. So, you will at the moment you look at it, you will know that wavelength is 3.28. There are two resonance lines for the determination of silver, 328.1 and 338.3, and the optimum slit width, that is the hollow cathode lamp radiation should pass through this is the mechanical slit width. Okay. Relative noise is 1, and that is the electrical noise corresponding to these wavelengths, and then characteristic concentration, this is the concentration where the determination is gives you the absorbance of 0.054. So, the use of characteristic concentration is, if you want to check whether the instrument is functional, whether it is good, are there no problems with respect to your samples etc., what you should do is prepare 2.5 ppm of milligram per liter, 2.5 ppm of silver, then you should get an absorbance of about 2.5 multiplied by 0.05, that is about 0.1 absorbance. Okay. So, if you multiply characteristic concentration and concentration check, this value should be multiplied by this, and if everything is all right, your solution is all right, your sample is all right, your standards are all right, your instrument setting is all right, your hollow cathode lamp is all right, your gas is all right, etc., you should get about 0.1 absorbance for 2.5 ppm of silver. The next range is, it will tell you up to what ppm you can prepare your standard solutions. Here it is written as 4 milligram per liter, that means you can prepare your standards 1, 2, 3, 4, or you can choose anything, but it should be below 4. Similarly, for if you choose this line 338.3, you can see that the characteristic concentration is double, that means this is not so sensitive. The first preference is 328.1. If for some reason if you are not able to get this line from your monochromator from your hollow cathode lamp, you can choose 338, but it will be at the cost of sensitivity. So, this 5 ppm is the at that time you should prepare 5 ppm of silver concentration, and it should give you 5 into 0.1 is approximately 0.5 absorbance, and working range is approximately double than this. So, this is how you should interpret the instrument conditions whenever you want to do an analysis. That means, they also give you what gas you should be using. Here they are recommending air acetylene, oxidizing. Yes, the oxidizing means it should be lean, blue color. So, you must adjust the gas flow rate in such a way that air should be more, acetylene should be less, and it must the flame must look blue when you are not aspirating anything. Okay. So, data obtained with standard nebulizer, etc., that is the concentration. This sensitivities, characteristic concentrations are calculated using data obtained with standard nebulizer and flow spoiler. So, operation with high sensitivity nebulizer will increase sensitivity. So, it depends upon the nebulizer. So, for this instrument which I have chosen, these are the conditions. So, characteristic, suppose you determine go for the determination of silver using nitrous oxide and acetylene flame at 328, the detection limit is 0.36 milligram per liter, that means 0.36 multiplied by this concentration would be the approximate reading. So, they will also tell you how to prepare your standards, samples and standards. They say use 5% volume by volume nitric acid to keep the element in solution. Sometimes what happens is you have to prepare the concentrations at low concentrations, they precipitate especially in parts per million ppb level, they precipitate, and after some time you will see that there is no signal. So, to keep the solution, to keep the sample in solution or to keep the solution stable, they recommend nitric acid as the standard component of the standard solutions. So, once you prepare these solutions, the samples will be stable for considerable length of time. You do not have to prepare the standards again and again. Okay. Now, the additional information they give you is wavelength, slit. Suppose you use 328 and 0.2 nanometer slit, you should be using, if you are using nitrous oxide acetylene flame for the same silver. So, all of this will be contained in one page. So, they say how to prepare a stock standard solution, and we will see what is stock standard solution, etc., after some time. So, you have to dissolve. so much of silver nitrate in 50 ml dilute to 1 liter. All these details are available in the manual. Okay. And then light sources. They say we use multi-element lamp or the multi-element lamp you can use, or you can use other lamp, silver, dedicated silver, but they will also give you some information about bromide interferences, bromide, chromate, iodide, etc. If they are there, they will be precipitating silver, large excess of aluminum. This is only to help you whenever you want to do signal. Some additional specific information they give you, for example, large excess of aluminum or mineral acids may depress the silver signal. So, if you do not get the characteristic concentration or absorbance for a known standard, look for such changes. Is there a lot of aluminum in the sample, like that you can check. And then they also give you some information, organic solvent effect. They say if you prepare the solution in 5% acetic acid solution, it will increase the sensitivity. Okay. So, these are the standard atomic conditions for aluminum. You can see that there are about 5 plus 5, about 10 resonance lines for atomic absorption, but their sensitivity characteristic concentration is almost comparable in the first 3, but lower in the remaining. But the recommended flame would be nitrous oxide, because it forms a refractory oxide. So, they say use reducing flame, that is rich and red. It should be, flame should look reddish. So, that is how you must adjust your nitrous oxide and acetylene. So, all other things will remain the same, and sometimes data they will give you this information, data collected with an alkali salt containing 0.1%, that is to adjust the ionic concentrations in your sample to control ionization. Okay. Now, similarly we can continue. They will tell you stock solution, interferences, etc. You can see that ionization is in a big interferent in most of the nitrous oxide acetylene flames. Okay. They will also give you information about doublets, etc. for aluminum. Now, for arsenic. Arsenic is one of the most difficult elements to do, because the resonance line is 193, that is almost UV. Okay. Here the problem is many of the organic compounds will give you molecular absorbance around 193, that is pi, sigma to sigma star or pi to pi star contributions, and n to pi star also. So, this signal is very difficult to handle, but and moreover the arsenic lamp, the intensity of the lamp also is not very good with respect to hollow cathode lamp. So, people prefer EDL, that is electrodeless discharge lamps. HCl sensitivity, hollow cathode lamp sensitivity data are about 25% poorer. That means the intensity of the radiation coming out from EDL is about 25% better than hollow cathode lamp. So, any element which has got wavelength resonance wavelength below 200, you must go for EDL, that is electrodeless discharge lamp. Okay. So, characteristic concentration also seems to be quite high, that is 45, etc. So, flame is not really good for arsenic. Arsenic hydride, yes, you will see the better sensitivity almost up to parts per billion level. Okay. So, then the other information is same, stock standard solution. They will give you a warning that it is arsenic is toxic, air acetylene flame absorbs or scatters more than 60%. So, some problem explanation for arsenic, so you should be very careful. They say use of background correction is recommended. Quite often we do not need background correction, because if the matrix is very simple. For example, if you want to determine elements in water, you do not need a background correction, not many elements will be there anyway. So, light sources HCl and EDL etc. in some interferences, and there is non-specific absorption. That is what I was telling you about the molecular absorption peaks from organic compounds in UV range, that is around 193.7. all right. So, this is how we interpret the manual in this atomic absorption. I have about another 6 or 7 slides for the different elements. Anything specific I will keep on I will mention that. For example, cadmium seems to be one of the best element for the determination using flame atomic absorption. You can see that detection limit characteristic concentration is 0.028 ppm. So, that is fantastic. So, you do not need really graphite furnace or something for the detection of cadmium, and 326.1 line is fairly not so sensitive, and the detection limit or characteristic concentration should be about 500 ppm. So, it is not very nice, but other things will remain the same. So, given a choice, you should choose 228.8 nanometer range from for cadmium, and they say HCl data is better, is okay, but EDL sensitivity values are slightly better. So, if you have EDL for cadmium, use it, otherwise go ahead with the HCl data, hollow cathode lamp data. Okay. So, you can see here even this linear range is only up to 2 ppm. Okay. So, you can determine really cadmium concentrations up to 2 ppm, which is good because cadmium is a carcinogenic element. Cadmium causes a disease known as itai itai in Japanese, which corresponds to approximately IIO. So, cadmium is good for flame. Similarly, other conditions are there, light sources, interferences. You can study these this kind of information at your leisure, or whenever you want to determine cadmium, go through this manual, or you can go through the any other manual available specific to cadmium. Okay. Now, for copper there are so many lines, but sensitivity, relative noise is much better for only for 324.8, 327, okay, and say detection limit is 0.077, and air acetylene oxidizing flame, that is it basically. Standard flame emissions, they say dissolve 1 gram etc. Light sources, hollow cathode lamp should be good. You can use multi element lamp also. So, gold, these are the 242.28 is the most ideal wavelength, okay, and characteristic concentration is 0.33 and characteristic concentration check is 15 ppm, that is 15 into 0.3 is about 15 3s are 45. So, approximately 0.45 is the check, characteristic concentration check, and then linear range is up to 50 ppm, air acetylene is advised, and sometimes if you want to determine at lower level you should go to nitrous oxide acetylene, but 90% of the time people do not want to work with air acetylene unless it is necessary. People prefer nitrous oxide acetylene. Nitrous oxide acetylene they prefer only when there is oxide formation. sensitivity is if the sensitivity is very low, you do not need. If the sensitivity is bad, you should go for higher this thing. Now, other conditions are all there in gold. They say you can use strong mineral acids also, and they say you maintain your standards in 10% HCl as far as gold and other noble metals are concerned. Okay. And for actual good analysis, because gold is a very precious element, you have to choose samples and standards should be matrix matched. That means, suppose there will be alloying elements etc., you have to add the alloying elements to see the correct signal. So, mercury, the usually hydride generation, but if you want to do it air acetylene, characteristic concentration is 4.2 milligram per liter, and for 0.2 absorbance you should use 200 ppm. Okay. And they say use EDL for mercury, and because the HCl sensitivity is poorer by about 25%. Okay. So, but if you choose this, nobody likes to determine mercury by atomic absorption, flame atomic absorption, because cold vapor gives you analysis of at ppb level straight away. So, mercury other conditions are there. Here I must say that you must be very careful whenever you are handling mercury. Mercury is a toxic element, mercury is a carcinogenic element, it affects the nervous system, it causes a disease known as nervous disease known as Minamata-Bay disease. You can look up the additional information from the textbooks. We will continue our discussion